Okay, let's go through this code right here. So it involves a function and a while loop. And one way to go through while loops that you might find useful is something called tracing. And what tracing does is we read out a table. We could do it on computer or using pen and paper. And this table basically has our variable names and the values with each iteration of the loop. So if we call do stuff, the name of the function, if we call it with a value of n equals 4, we have two variables that we're looking at. We have answer, and we have n, which is 4 when we call it with a value of 4. And we keep track of it with a tracing table. In the first iteration, before we've even entered the loop, we have n equals 4, answer equals 1. Okay, well, let's see what happens when we go through the loop, through the while loop, and how these values change. And what's the answer overall going to be after the 4, or after the number of iterations for n equals 4. So we'll print do stuff 4. What's the answer going to be? So we see it's 24. But we don't yet know why we're going to get that number. So let's go through it. Let's use our tracing table. You can follow along with pen and paper, but I'm just going to use the comments up here to keep track of our values. So we start with answer equals 1, and we called the function with n equals 4. So these are our initial values. Let's go into our function, and we have answer equals 1, n equals 4. When we go into the loop, 4 is greater than 1, so this is true, and so we go into our loop. Answer is going to be reassigned in the loop to itself times n. Answer was 1, n was 4, so we multiply 1 by 4. Answer is now going to be reassigned the value of 4. N is also going to be reassigned to its previous value, 4, minus 1 is 3. So n will be 3. Answer is 4, n is 3. So in the second row of your table, you can record that n has a value of 3, answer has a value of 4, and we'll keep going. So this loop here, the while loop, doesn't actually end right now because n is still greater than 1, n is 3. So n is 3, this condition is true, so we enter the loop and reassign answer to be answer times n. N is 3, answer was 4, 4 times 3 is 12, so answer will now be 12. What about n? N is going to decrement by 1, it will become 2. Going back to the loop, is 2 greater than 1? Yes, so we'll go into the loop again. Answer is going to be reassigned to be the previous value of answer, 12, times the previous value of n, 2. 12 times 2 is 24. And n will decrement by 1, or decrease by 1, so n will now be 1. Do we enter the loop again? No, because 1 is not greater than 1. This is false, so we don't enter the body of this while loop, and we then go to here, we return the answer, and the answer was 24. So that's why we get a value of 24 for this function. And tracing is a good way to go through your program and make sure you know what's going on. Another side note, instead of writing a equals a plus 1, we can write a plus equals 1. It's just a shorthand. And I just wanted you to note this because you might see some programs when you're looking through someone else's code where they write a plus equals 1, or in the case of minus, we could have n minus equals 1, which is the same thing as saying n equals n minus 1. So So if we run this, we'll get the same answer because this doesn't change. It's the same as writing n equals n minus 1. Okay, we'll finish the video off with a few key terms. First one is encapsulation. So what does that mean? It's a long word, but all it really means is putting your code into a function. So if we took this while loop and we put it into a function, that's encapsulation. That's encapsulating that code into a function. Generalization, another long word, but it just means to generalize something to make it more general. So instead of a specific value like 5, we have a value of n or some variable name. How could we incorporate that? Let's look at this example. Not how could we incorporate that? How could we incorporate these two mechanisms, encapsulation and generalization? We start with encapsulation. We have some code here in a while loop, and we want to encapsulate that. So we can put it into a function. We'll call it print multiples. And we can give it a argument for I, and we can return I. Okay, and what this will do, this will take our value for I. It'll say while I is less than 5, we'll print double I. We'll print 2 times I. So what we've done here is we've encapsulated this while loop into a function. How can we generalize this now that we've encapsulated it? Well, instead of having 2 times 1, we could have n times 1, and that way our function is able to multiply our input value by 2. It can create doubles, but it can also create triples, quadruples, multiplied by 10, 1,000, and so on. So because that has more options than 2 times I, we would say that's generalization. It's a more general function. So that's it for this class. For next week, just read chapter 7 and make sure that you have activity 2 done by Friday night before midnight. So that's it. Happy Thanksgiving and have a great week.